Good morning, my dear students. Welcome back to surveying. Myself, Professor H. Narendra Kumar, would like to continue with chain surveying, where I left in the previous class. I think I left my discussion in the different types of chains that are used in chain surveying. Okay, let me go to that slide. Okay, my dear students, this is where I left my class. Once again, for the continuity purpose, let me go through this slide. So this is the different types of chains that are essential in chain surveying, like Gunter's survey chain, revenue chain, engineer's chain, and metric chain, and steel band. As I said earlier, the steel band is one of the ultimate linear measuring instrument used for precise measurement. You know that baseline is one of the most important line in chain surveying. So we can able to make use of the steel band, also called as band chain, for precise measurement, and it is also available in lengths of 20 meter and 30 meter. So this is where I left actually in the previous class. This is the process that is being employed in chain surveying. What exactly we do in chain surveying? Before getting into the chain surveying, first of all, we need to understand the terminology that is ranging. What is ranging, my dear students? Ranging is nothing but process of locating intermediate points on survey line. So you know that actually the chain is made up of 20 or 30 meter. Whenever the line is more than the chain length, we need to mark intermediate stated points in order to measure the line in a straight line. So that process, okay, please understand, that process of locating intermediate points, okay, on the survey line. Why we need intermediate points? Because in order to measure the length AB, we need to mark C, D, etc., on the chain line. So this process is called as ranging a survey line. So the methods of ranging are classified as direct ranging and indirect ranging. Once again, I repeat, direct ranging and indirect ranging. So the name itself gives you an idea. Direct ranging is nothing but the extreme points A and B are visible, intervisible. So when there is an intervisibility, we can go for direct ranging. Okay, for direct ranging, we don't require any instrument. Okay, we can make use of our eye, called as eye ranging. So by keeping ranging rods at A and B station, we can place another ranging rod at a suitable distance less than the chain length. Okay, less than the chain length, so that we'll get a straight line. So all the three ranging rods are coinciding. Okay, so this is called as direct ranging. Then what is this indirect ranging? For example, you can see here, there is A point here, there is B point. Okay, there is a small mound, not a hillock. Please remember, it is not a hillock like Nandi Hills. It's only a mound, so that you can cross over from A to B, but there is no intervisibility, right? There is no intervisibility. That is nothing but if you stand at A point, B is not visible. When you stand at B point, Obviously, A is not visible. So what we are going to do is, then we are going to do what is called as indirect ranging. So what is that indirect ranging? Randomly we select the stations M1 and N1. Okay. Then the person who is standing at A will call the M1 to a point M2 such that A, M2, N1 is in a straight line. Please understand. So first we need to select random points away from the chain line, because we don't know actually those 2 points are on the chain line because there is no intervisibility. So what I'm going to do is I'm going to select random points M1 and N1. Then a person standing at A will call actually the M1 person to move towards the chain line such that he is going to occupy a station point M2 such that A, M2, N1 is in a straight line. Then the B person will take over. He is going to call actually the N1 person to move towards the chain line, occupy a position N2 such that B, N2, M2 is a straight line. So this process is being repeated several times. Finally, they are going to arrive at station M and N such that AMN is a straight line. Similarly, BNM is a straight line. So at that particular stage, we can able to say M and N are there on chain line AB. This is a very, very slow process. Since A and B are not intervisible, we need to go for indirect ranging. This is also called as, please do remember, reciprocal ranging. Okay, reciprocal ranging. Why it is called as reciprocal ranging? Because the people standing at M and N reciprocates to the instructions given by the people standing at A and B. They reciprocate simultaneously to move towards the station M and N. Okay, so this is a very, very slow process, but this is a wonderful process in order to mark the intermediate points and a chain line when the stations are not intervisible. When they are intervisible, the process is very, very simple. We'll go for direct ranging. So when actually the chain survey is suitable, when you are going to employ the chain survey, I'm going to detail it point wise. Okay, whenever the area to be surveyed is comparatively small. Okay, this you need to remember. When the area is comparatively small, we'll go for chain surveying. Okay, for example, if somebody asks me to do chain surveying for the entire Bangalore city, then it's not possible. Possible, but it will take years together, right? So whenever the area is very small, then we can go for chain surveying. And the second point to be noted down, the ground is fairly level. Then chain surveying is easy. Or otherwise, you know that just now we discussed about ranging. We need to go for a reciprocal ranging or indirect ranging. It's a cumbersome, complicated, time-consuming process. So if the ground is fairly level, then there is no problem with intervisibility. Then I can go for chain surveying. Area is open. This is also an important one. If area is bushy area, okay, having a lot of trees, then it is going to hamper our surveying. Then details to be filled up are simple and easy. So if the details that I need to catch, okay, the buildings or any other natural resources that I need to actually take up in my surveying, then if they are simple and less number, then I can go for chain surveying. What about not suitable conditions? Area to be surveyed is large. So as I said earlier, if it is a large area, then it is a very, very complex process. The ground is quite uneven. Whatever that is being written, if you write actually the reverse of it, then it is not suitable. Area is a crowded area. Lot of features are there. It is difficult for me to gather the information. Then it's very difficult for me to go for chain surveying. Details that are available are too many. Too many details are available. That is very difficult for me to capture. Okay, let us understand the various terminologies that are essential in chain surveying. So already I said something like station and other things, okay? So what exactly the meaning of all these terminologies that are used in chain surveying? Because this is essential in order to understand the chain surveying, right? So for that, in order to explain the various terminologies, I've taken up this particular diagram. Okay, this diagram gives me the complete information about the chain surveying. First, terminology. Station. So what is a station in surveying or chain surveying? So a station is a point of importance at the beginning and at the end of a survey. Okay, at the beginning and at the end. So that means to say minimum number of stations required is 2. One is at the beginning of survey, other one is at the end of survey. So here, if you look at here, the diagram, you can see a lot of stations. Okay, A, B, C, D, E, and as well as the small a, B, C, D, and similarly F. So all these things are stations. In that actually there are different types. First one is main station. What is a main station? These are the station at the beginning or at the end of lines. Okay, beginning at the end of lines. So main skeletal A, B, C, D are nothing but main station. A, B, C, D, E, F. These are all main station. Then what is this subsidiary, or we can say secondary, okay, or auxiliary stations? Okay, different names are there. So subsidiary stations, these are stations selected on main lanes. So we are going to select these stations on the main lanes to run auxiliary secondary lines. Okay, for what? For the purpose of locating interior details. See, my dear students, look at the diagram. There is a building here. So I need to get the details of this building. So what I'm going to do is, I'm going to run the secondary lines. Okay, you can see a lot of secondary lines. So all these secondary lines will be marked with the subsidiary station. You can see here, A, B, C, D. These are all actually called as subsidiary station. Then one of the most important terminology, baseline. What is a baseline? The most important line, longest line. Okay, one of the most important and the longest line in the network of our survey is called as a baseline. Okay, you can see here, AD is a baseline, longest line. And one more important information that I would like to give now, this baseline will be selected on a flat surface, on a plane surface preferably. Main framework of survey line are built on it. So first of all, we run the baseline and the network of the survey or the framework of the survey is built on it. For example, you can see here, AD is the baseline. Then we are going to build actually the framework like ABF, DCF, similarly BFC, okay, and similarly AED. Like that, you can actually create framework using this baseline. Why we are going to involve the baseline in order to create actually the or build the framework? Because baseline will be measured with utmost accuracy. Okay, since actually it is being measured with utmost accuracy, the baseline is used in order to build the entire framework of the survey. Then there is another line called as a detail line. You can see here, this is the detail line. Okay. So what is the purpose of detail line? So important objects are far away from the main lines. They are far away from the main lines. So offset formed is large. So if you would like to take up actually the perpendicular offset or oblique offset or any type of offset, then it is very large. The distance is very large. So which results in inaccuracy and time consuming in the field work. If it is more than the tape length, then you require actually once again ranging for taking the offset. Time consuming. So that is why we'll go for what is called as detail lines. In such cases, secondary lines, also called as detail lines, are taken care of. Next one is check lines. Important terminology. So a part of the sentence is highlighted there. Please look at here. What is the main purpose of check lines? To check the accuracy within the main station. So the main purpose of check line is to check the accuracy of the main stations. Okay, these are the lines connecting main station to a subsidiary station. So check lines, why they are subsidiary? Main station to a subsidiary station. Okay, similarly, a subsidiary stations will be connected using the check lines. So on the sides of main lanes, the purpose of measuring such lines is to check the accuracy within the main station. Are located, these lines are also known as group line. Please do remember, another name for check line is called as group lines. They are grouped together in order to check the accuracy of the survey work. Civil engineers, we need to remember, whatever we do, even if it is marking of the plan of a simple residential building, we need to check our marking using check lines. Okay, so these check lines on the ground as well as on the plan should actually have the same length. You got it? What is the purpose of check line? So check line gives us actually complete information about the accuracy of our framework. So next one is tie line. So the name itself gives you an idea. This tie is nothing but tying actually the different subsidiary stations. Okay, we are going to tie together. So the tie line is a line which joins subsidiary and tie stations to the main line. The main object of running a tie line is to take the details of the nearby objects. So in order to take the details of nearby objects, I am going to actually take the tie line. Sometimes the tie line also serves the purpose of check lines. So the vice versa is also true. Check line can be used as a chain line, and a tie line it can be used as a check line. Okay, these are all the important terminologies in our chain survey. Okay, so what are the points to be considered in selection of station? Okay, this you need to remember. What are the points to be considered in the selection of a station? So there are several points. Let me go through one by one. First and foremost requirement while selecting a station is the station selected should be visible from at least two more stations. Okay, so see, you need to actually connect this particular sentence with the principle of surveying. Okay, what is the second principle of surveying, my dear students? The second principle is nothing but, in order to mark a new station, there must be two measurements. Minimum two measurements should be considered in order to mark a new station. This is our second principle. So, if a station is visible from at least two more stations, then only the second principle holds good. Right? Otherwise, second principle will not hold good. To mark a new station from two independent measurements. So if I would like to mark a new station, So there must be intervisibility. Otherwise, you cannot actually mark a new station. Next one is mainframe should have as few lines as possible. So as we discussed earlier in the previous case, there is a check line, there is a tie line, and there is a detail line. Anyhow, it is there actually in our theory. Let me consider any number of lines. No way. More number of lines creates lot of the accuracy issues because it consumes more time. So that is why mainframe should have as few lines as possible. Try to minimize the number of lines taken in the framework. The third is a very, very important. That is why it is written actually in red color. Please do remember, all triangles should be well conditioned. Okay, well conditioned. Please remember this, well conditioned triangle. What is a well conditioned triangle? Okay, this you are going to actually study in mathematics. This is a typical triangle used in our survey work. Well conditioned triangle is that triangle in which the angles are greater than 30, less than 120 degrees. So I checked actually the last 8 years question papers. Okay, this appeared in almost all the question papers. You got it? The importance of this particular terminology, well conditioned triangle. So under the selection of station, okay, there is a point to be considered. That is, all the triangles that are created in a framework of surveying. Okay, forget about chain surveying. In any type of surveying, the triangles must be well conditioned triangle, greater than 30 degrees and less than 120 degrees. If you are interested, why actually 30 degrees and 120 degrees? If you look at the sine series and cosine series, okay, sine 0 is 0, sine 30 is 0.5. From sine 30 to sine 90, the next 0.5 is falling. So if you commit actually mistake in first 30 degrees in angular measurement, then in the calculation of linear values, then it actually multiplies. Okay, so that is why always the angles must be greater than 30 degrees and obviously less than 120 degrees. It's nothing but it should not be too acute, not too obtuse. So acute angle triangle, obtuse angle triangles are not considered in survey. So those triangles are called as well conditioned triangles. For example, if there is any question, a problem, okay, I would like to take up actually in some time after the completion of the syllabus. Okay, I would like to take up few problems that deals with well conditioned. For example, they are going to give us the data. You need to actually check whether this triangle is a well conditioned triangle or ill conditioned triangle. Okay, so that is also one way of calculation. Okay, one way of calculating the given triangle is a well conditioned triangle or ill conditioned. Ill condition is nothing but less than 30 degrees, greater than 120 degrees. They are not conditioned. If it is a well conditioned triangle, obviously it should fall between 30 degrees and 120 degrees. Okay, please do remember these two values. Okay, next is each triangle should have at least one check line. Okay, this is the requirement. Whatever the triangle that is being created in the framework should have one check line in order to check the accuracy of that particular triangle. Subsidiary station should be selected such that offset to main object from subsidiary lines are as short as possible. So if you take offset, it should be as short as possible. So as I said earlier, thumb rule says the offset should be less than the tape length. If it is less than the tape length, then the accuracy of the measurement is more. Otherwise, once again, in order to take actually the perpendicular offset or oblique offset, you need to actually go for ranging the offset. Okay. If it is more than the length of the chain or tape. Next one is, if possible, should have one or two baselines which run on level ground and through the middle of the area. Usually they say consider two baselines instead of one single baseline. For example, let me draw a simple sketch here. If this is the area that is considered, okay. So the selection says at least you should have two baseline crossing over. Okay. So if possible, this is not mandatory. Okay. This is not a mandatory requirement, essential requirement. Essential requirement is nothing but at least you should have two baselines which run on level ground and through the middle of the area. You can see here, both the baselines are crossing over in the middle of the area and they are the longest lines. Avoid obstacles to ranging and chaining, because if obstacles are there, then it is going to create a lot of problems for you to cross over. That itself is another topic, my dear students, that I would like to discuss in detail. See, the obstacles may be for ranging, obstacles may be for chaining, or obstacles may be for both ranging and chaining. These are all the three classes of obstacles. So if I would like to give examples, okay, for example, there is a mound. We did actually that reciprocal ranging, right? That is also one type of obstacle. If it is a hillock, then I cannot go for reciprocal ranging. Then what I'm going to do? I'm going to consider what is called as random line method. Random line method. Okay. So this random line method is nothing but taking a random line away from the obstacle in order to cross over. And there may be a pond, a water body, a river, a building. So these are all the different classes of obstacle, my dear students. Next one. As far as possible, survey line should be on the level ground. This I said earlier. As far as possible, survey line should be on the level ground. Why it should be there on the level ground? Because if there is a mound, then we need to go for what is called as reciprocal ranging, because there will be intervisibility problem, right? Okay. Then we discussed about offset in the previous slide, right? So how to erect offsets in the field? So there are different methods of erecting the offset. This basically makes use of what is called as the simple geometrical construction that we discussed actually in our high school. Okay. Dropping a perpendicular, erecting a perpendicular. These are all the terminologies that we already learned in our high school. The same geometrical construction is being used in our survey work. See, basically the survey work is made up of geometry and trigonometry. Higher order mathematics is not at all required for the basic surveying. Only for advanced surveying, we require actually the higher order mathematics. Whereas for basic surveying, our simple geometry and trigonometry, whatever that is being learned at the high school level and PU level is more than sufficient. Okay. So there are two, you can say the types. One is erecting perpendiculars. The second one is dropping a perpendicular. Please understand the technicality behind these two sentences. To erect perpendicular, erecting a perpendicular to a chain line from a point on it. Erecting a perpendicular is nothing but here, please look at actually the diagram. The point is there on the chain line. So we need to erect a perpendicular with respect to this point. It is nothing but we need to erect an offset, a perpendicular offset. So the simple way is nothing but 3, 4, 5 method. Okay, 3, 4, and 5 method. Everybody knows that this is a right angle because 3 square plus 4 square is equal to 5 square, right? This we learned actually in our even the high score. So using this, we can easily erect a perpendicular using 3, 4, 5 method. Simple way. Next one is nothing but we can erect a perpendicular from C by taking equal. CE is equal to CF. Is nothing but you take CE distance and CF distance, equal distance. Okay. Then ED is equal to FD. ED is equal to FD. So this is another way of erecting a perpendicular. Please do remember we are erecting a perpendicular. Next one is another complex process. C is the point. Okay. So you take one random point F and FC as radius, draw an arc. Okay. Please look at the diagram. Draw an arc. So this arc cuts actually chain line at E point. Join EF. Continue it till you reach D such that EF is equal to FD. From D, join DC. This is nothing but erecting perpendicular. Okay, this is another way. Now, to drop a perpendicular to a given chain line from outside a point. Here, the point is outside the chain line. See here, the point is outside the chain line. We need to actually drop a perpendicular. So, how to drop a perpendicular? Take the measurement greater than the distance and draw an arc. So you can see here, draw an arc. This arc cuts the chain line at 2 points. So bisect it. That is nothing but the tip of the perpendicular. Join DC. Here we are erecting the perpendicular. Here we are dropping the perpendicular. That is the technical difference between erecting a perpendicular, dropping a perpendicular. Similarly, here, once again, draw an arc and bisect it. C is equal to CF. And this method is very much similar to the previous method, right? So you need to consider a point outside the chain line, then draw an arc. Okay, this arc cuts actually at E and C, right? Such that EF is equal to FD. Then you can easily drop a perpendicular. So these two methods are much similar. All these methodologies uses what is called as simple geometrical construction, right? So if you are good at geometry, you can create, let me tell you, you can create your own methodologies for erecting a perpendicular. Okay, so here erecting a perpendicular involves erect the perpendicular to a chain line from a point on it, or dropping a perpendicular to a given chain from outside point. Both are possible in our chain surveying. Then the instrument which is essentially used in our chain surveying. Okay, so the previous method is nothing but the geometrical construction. Okay, if these instruments are not available, okay, unfortunately we forgot to carry this instrument to the field. So what to do? Then we go for the dropping a perpendicular or erecting a perpendicular. But if instruments are available with us, like optical square, okay, so please do remember this, because I checked actually in one of the question paper, what is the principle behind the optical square? The principle behind the optical square is double reflection. Okay, so double reflection is the basic principle behind the optical square. So in order to explain that, I've taken this particular slide. So the optical square is a small hand instrument. You can use actually your hand to make use of the optical square. Hold the optical square in your hand. That's all. Very easy to make use of. So in order to lay off what? Angle. So in order to erect right angles, we are going to make use of optical square. So this optical square, the basic principle is nothing but double reflection. I will come back to this explanation. Let me explain this diagram first. See here. This is the one station. This is another station. Okay. I need to erect perpendicular or lay up perpendicular. This is where I am standing. My eyes is there. Okay. There are two mirrors here. You can see here. One mirror here, another mirror here. These two mirrors are provided in such a way that the angle made by these two mirrors, okay, is equal to 45 degrees. Okay. So here the rays will pass through this mirror because it is half grounded, half clear. Please understand, this is half grounded, half clear. So that in half of the portion, the rays pass through it. You can see the ray. Whereas the light ray which comes from this particular point hits the mirror and reflected back, or you can say deflected back to this mirror, and once again it passes over. So these two ranging rods kept at these 2 points, if they overlap one above the other like this, okay, then you can say the points are at right angle to each other. So you need to use actually the optical square handheld instrument. If you can able to remember your undergraduate level second year, in which while conducting chain surveying, okay, we are going to make use of optical square by holding the optical square, okay, like this in front of your eyes, okay, exactly in between, so that these two ranging rods will overlap. Okay, one is the reflected image, the other one is the direct image. If they overlap, then you can say that you are standing on a point in which it creates a right angle. Okay, it's a wonderful instrument. And what is more important for us is nothing but the principle behind it, double reflection. Okay, here you can see here, the rays which comes here will be reflected from this mirror to this mirror. Once again, from this mirror, it will be reflected back to the surveyor. So that is why it is called as double reflection method. The principle is double reflection. So in order to get that principle, in an optical square, the angle made between the two mirrors is fixed at 45 degrees. If the angle is exactly at 45 degrees, then the angle between the horizon side and the index side is equal to 90 degrees. So you need to make actually that 45-degree angle between the two mirrors. That is nothing but the calibration for the optical square. There is a screw in order to move that mirror. Okay, those two mirrors can be operated using a screw. So in the calibration, okay, the experts will make use of those screws in order to create 90 degrees. Okay, so that means to say those two mirrors are at an angle of 45 degrees to each other in order to create what is called as double reflection. Okay, my dear students, before taking up simple problems, if you are having any books with you, please in my class, keep a book, notebook and a pen. You need to work along with me, okay? Because numerical problems, you need to work. If you work actually, then you will understand. Okay, now there is a problem with our chain. The chain is incorrect. So this particular topic deals with error due to incorrect chain. Okay. So there are different types of error that we'll consider actually in our chain surveying. True length of the line, incorrect chain is there. Okay. So if you measure actually any line using this incorrect chain, how to calculate the true length? This is the numerical problem. Okay. You are making use of a chain. Unfortunately, the chain is not correct. or otherwise it may be correct in the beginning of the surveying due to mishandling. Okay, at the end of surveying, you got to know that the chain is not correct, it is incorrect. So in such a case, what are you going to do? Are you going to repeat the whole process, whole measurement once again? It's a very complex measurement because you already covered somewhere 1.5 to 2 kilometers distance using this incorrect chain. So what to do? So what we are going to do is we are going to make use of our mathematical calculations in order to calculate the true length of the line. So what is the true length of the line? It is nothing but L by L, small l by capital L. This is small l, my dear students. Okay, small l by capital L multiplied by measured length. So when you are going to make use of this formula, when we are using an incorrect chain, okay, due to this incorrect chain, there is an error. So we need to calculate the true length of the line using this formula. Once again, I repeat, simple formula, L by L. Take the ratio between L by L multiplied by measured length. So there are two components here, terminologies, L and L, small l and capital L. What is that small l? Small l is the incorrect length of the chain. So 30 meter is the chain length. If it is 30.1, so that is incorrect length, right? Incorrect length of the chain. Second, capital L, the true length of the chain. The true length is nothing but 30 meters. Okay? Incorrect length divided by true length. Please do remember. And here there are certain sign convention. Plus sign when the chain is too long. If it is too long, instead of 30 meters, if it is 30.1 meter, so you need to make use of plus sign. You need to add, because you are measuring actually the length thinking that it is 30 meters, but you are measuring 30.1. You are over measuring it. Okay, you need to add. So minus sign when it is too short. If it is instead of 30 meters, 29.9 meters, 29.85 meters, then you need to use minus sign here. Okay, that you learn actually in the problem. I believe that you are copying this equation. Error in area due to incorrect chain. So you are making use of this chain for the measurement of area. Then how to correct the area? So true area, okay, true area is given by same thing, L by L, okay. This is small l by capital L whole square multiplied by measured area. L by L whole square. If it is length, L by L. If it is area, L by L whole square multiplied by measured area. Similarly, when you are using actually for volume measurement, error in volume due to incorrect chain, then it is L by L whole cube multiplied by measured volume. Okay, the formula remains the same. L by L is there for the length, L by L whole square for area, L by L whole cube for true volume. Right? So usually this will not come into picture in our surveying. We are not going to measure the volume, right? In surveying, basically we measure the length, we measure the area. Volume measurement is rarely we do it, rarely. Okay? Most of the time volume will be calculated using areas and volume, using mathematical calculations, using contour applications, right? I don't think so we are going to make use of the chain for the measurement of volume. Rarely we use. Okay, now let us take up some numerical problems. These are all simple problems. Okay, once again I repeat, I think you are using actually the books and pen. Please keep a notebook and a pen. Always make a note of it. Okay, first problem. The length of a line measured with a 30 meter. Okay, this is 30 meter. 30 meter chain was found to be 634.4 meter. 634.4 meter. It was afterwards found that the chain was 0.1 meter too long. find the true length of the line. So they measured 634.4 meters using a chain of 30-meter length. But after completion of the survey work, okay, the surveyor got to know that the chain which was used was 0.1 meter too long. It is after measurement, okay, and we need to calculate the true length. We cannot leave it as it is, because 0.1 meter is not a small error. Okay, we need to actually correct using our the equations that we learned earlier in the previous slide. So here we need to make certain assumptions. What is the basic assumption made usually in these type of problems? The basic assumption made in this type of problem is, my dear students, we assume that the chain was correct actually in the beginning of the surveying. That is nothing but at the beginning of the surveying, the chain is exactly 30 meters. You got it? The chain is exactly 30 meters. So upon the completion of the measurement, the chain was 0.1 meter too long, because you know that during the measurement we pull the chain. Okay, you know that actually a 30-meter chain is having 150 links. Each link is made up of 20 centimeter, 0.2 meters, right? So when you pull, actually, obviously it is made up of a lot of rings. So it expands. So there is an error of 0.1 meter. But our assumption says at the beginning of survey, the chain was correct. Only if you assume like that, then only we can able to solve this problem. Otherwise, it's not possible. Right? You cannot say actually it was correct in the beginning. Even actually after measurement of 50% of the length, it was good. It's not possible. Okay, we need to assume the chain was correct at the beginning and it was too long at the end of 634.4 meter at the end of surveying. So if you assume like this, we can able to solve this problem. Okay. Okay, look at the solution, my dear students. I did actually in 3 levels. First is true length of the line. So we need to write actually this equation. Okay, we already learned L by L. L by capital L, small l by capital L, multiplied by measured length of the line. Okay, what is actually the small l? Incorrect length of the chain. It is 30.1. It is given in our problem, right? 30.1 meter. Simple problem. This is the type of problem that you will come across actually in the examination, because you know that this is MCQ type. Only 2 marks problem will be given actually in the examination. So these are all the problems that you can expect actually in the examination. So 30.1 is actually the incorrect length of the chain. Okay, true length of the chain is 30 meter. Measured length of the line is, it's given in the problem, 634.4 meter. So just a substitution. Okay, I got to know this is small l. Okay, small l is 30.1, capital L is 30, and multiply by measured length of the line is 634.4. So the corrected, the true length or the corrected length, whatever it may be, the true length of the line is 636.51. Okay, this is the answer. You got it? So simple problem. L by L. L is the incorrect length of the chain. Capital L. Okay, small l is the incorrect length of the chain. Capital L is the true length of the chain. And measured length is given as 634.4 meter. So substituting all these values in the equation. Okay. So I'll get 636.51 meter. Okay, this is one problem. Next, it's a combination. combination. Okay. Let me explain. First, let me go through the problem. A 20-meter chain. Here, instead of 30 meter, we are using 20 meter. (20-meter) chain was found to be 0.05 meter too long after chaining 1400 meter. Okay, please do remember these values. 0.05 meter too long after chaining 1400 meters. So what is the basic assumption made? Once again, I repeat, the chain was correct at the beginning of survey. The chain was correct at the beginning of the survey. It was found to be 0.1 meter too long after chaining 2200 meter. Okay. So it was found to be 0.1 meter too long after chaining 2200 meter. If the chain was correct before the commencement of the work, okay, an important information, my dear students. The chain was correct before the commencement of the survey work. Find the true distance. So what I'm going to do is, I'm going to write a diagram here in order to make it as simple as possible for you. So what is the total distance measured? It is 2200 meter. Okay. So let me draw a line. Okay. So this is 0 meter. This is 2200 meter. Okay. In the first phase, the 20-meter chain was found to be 0.05 meter too long after chaining 1400 meter. So let me mark actually 1400 meter. So this is 1400 meter. So after measuring 1400 meters, they got to know some problem is there with the chain which is employed. So it was correct actually at the beginning, right? It is given in the problem. The chain was correct before the commencement of the work. So the error is 0. I'm going to write here. The error is 0 at the beginning. Okay. And 0.05 meter too long. 0.05 meter. Let me draw once again. Okay. This is 0. This is for 1400 meters. This is 2200 meters. So 0, 1400. And this is 2200. Okay. 0, that is no correction. Then 0.05. Okay. Next, 0.1 meter. Okay. Now I'm going to explain. Please listen to me carefully. The error was 0 at the beginning, whereas the error was 0.05 meter after 1400 meter. So what we need to do is we need to calculate what is called as mean elongation. What is that mean elongation? The average between 0 and 0.5. 0 and 0.05. Okay. That is the average elongation, mean elongation for the length 1400 meters. Similarly, for the length 800 meters. See, 1400, 2200. So this is nothing but 800 meters, right? And this is 1400 meters. So I'm dividing this into two parts. One is 1400 meter length, other one is 800 meter. For the 800 meter, the mean elongation is the average between 0.05 and 0.1. Okay. So that calculation is the preliminary calculation before applying the formula. So I need to calculate what is called as mean elongation. Whereas in the previous problem, they never mentioned about actually this sentence, the chain was correct before the commencement. They never mentioned about it. Okay. If there is a sentence like that, then we need to calculate mean elongation even in the previous problem. Since it was not there, we don't require actually the mean elongation calculation in the previous problem. But here it clearly says the chain was correct before the commencement of the survey work. So that means to say I need to calculate the mean elongation. Now let me show the calculation part. Okay. So that explanation, whatever I did, is written here. Since the chain was correct, that is 20 meter long at the beginning and was 20.05 meter, 20.05 meter long after chaining 1400 meters. Please do remember that diagram. So assuming the increase in length was gradual, so it increased from 20 to 20.05 gradually. So there is an elongation, gradual elongation during the measurement of 1400 meters. So I calculated mean elongation by taking the average 0 and 0.05 divided by 2. So I got the mean elongation 0.025. So what happens then? The incorrect length of the chain becomes 20.025 because I'm going to add this 0.025 to 20 meter length. So it becomes 20.025 divided by 20 multiplied by 1400 meters. So if you calculate, if you are having calculator, you can do it. 1401.75 meter. This is for the first measurement. Okay, for 1400 meters. Okay, the true distance is 1401.75. This is for the first part. What about for the second part? Okay, for the second part, the remaining distance. What is the remaining distance? I already written in the diagram. That is 800 meters. Okay, that is 2200 minus 1400. For 800 meters, using the same chain, it was found 0.05 meter too long at the beginning of the commencement of the chaining of this distance. That is at 1400 meters, the chain was 0.05 meter long and 0.01 meter too long at the end of chaining 2200. So at the beginning of 1400 meters, it was 0.05. At the end of 2200, it was 0.01. What is the mean elongation then? Mean elongation is nothing but 0.05 plus 0.10 divided by 2. Then it becomes 0.075. This is the mean elongation for what? For 800 meters distance measurement. So I'm going to make use of the same equation, that is true distance 20.075. I need to add actually 0.075 to 20 meter. So incorrect length of the chain, right? 20.075 divided by true length of the chain 20 meter multiplied by what is the distance measure? It is 800 meters. So I'll get 803.0 meters. So one is 1401.75. Another one is 803. I need to combine these two. Okay. So if I add these two, okay, let me show this. If I add these two, total true distance 1401.75 plus 803. So it is 2204.75. So if I am not using this correction, then the error will be 4.75 meter. Okay, so that is why in surveying, the important point to be noted down is always when you found actually error in the instrument, use your mathematical sense. Use your mathematical sense in order to correct that error. Okay. See, let me tell you, these are all not great equations. They are nothing but ratio and proportions. Very simple. For 20 meter, it is 20.075. For 800 meters, what is the correction? Okay, simple. Ratio and proportion that we learned actually in our 5th or 6th standard, right? So if you remember that concept of your basic mathematics, our problems are so simple. Next problem. A child was tested before starting a survey and was found to be exactly 30 meters. So no problem with the chain at the beginning of survey. Exactly. Okay, let me underline, please, because I would like to bring to your notice the important point. Exactly 30 meter. Okay, that means to say they checked before getting into the work the length of the chain exactly 30 meters. At the end of the survey, it was found to measure 30.15. Some error. Okay, 30 meter was there in the beginning, but after the completion, they got some doubt and checked once again. It was 30.15. The area of the plan drawn to a scale of 1 centimeter to 2 meter. So 1 centimeter is equal to 2 meters. This is the area of the plan drawn to a scale. After this measurement, okay, they created a plan by taking a suitable scale. 1 centimeter is equal to 2 meter. And that area is equal to 140 square centimeter. 140 square centimeter on the plan. Find the true area of the field. Okay, they created a plan and they got the areas 140 square kilometer, and we need to calculate what is the true area of the field by applying that correction as well as by applying this scale factor. Okay. So this is a two-step calculation. First step is as usual. Since the chain was correct, that is 30 meter long at the beginning, 30 meter long. 30 meter long at the beginning and was 30.15 meter long after chaining. So as you know, actually, if it is correct at the beginning and there is a problem at the end, we need to calculate what is called as mean elongation, right? So the mean elongation 0 at the beginning, 0.05 after the completion of the work. So mean elongation, mean is average divided by 2. So 0.075 is the mean elongation. So if I add 0.075 to the chain length, it becomes 30.075. Incorrect length of the chain, small l by capital L. What is the formula? Once again, let me write here, L by L whole square. Okay, multiply by measured length. Measured length. Or here it is measured area. Right? Because we are calculating area. L by L whole square multiplied by measured area. So L by L, 30.075 divided by 30 whole square multiplied by 140. It is given in the problem itself, 140 square centimeter. So it becomes 140.7 square centimeter. Please use the calculator. Please use the calculator and tell me the answer or check the answer. Please check the answer after doing, because if there is any mistake in my calculation, okay, let me rectify. Okay, this is 140.7 square centimeter. This is on plan. The correction is on plan. But what the problem says, we need to calculate actually the correction on the field. Okay, how to calculate? Please look at this. The sentence which is given in this black and red color. The scale of the plan being 1 centimeter is equal to 2 meter. That is 1 centimeter on the plan is equal to 2 meter on the field. If you measure 1 centimeter on the plan, it will be 2 meter in the field. So the true area of the field is 140.7 multiplied by 2 square. Okay, because 1 centimeter is equal to 2 meter. So how I can showcase? See here, 1 centimeter is equal to 2 meter. Then 1 square centimeter square is equal to 2 square meter square. Simple. Because we are calculating area, right? So that is why whatever the area that is being calculated, multiply by 2 square. Because multiply by what is that measured area? That is the true area which is calculated 140.7. So you will get 562.8 meter square. So this is the calculation for area. Okay. So this is nothing but a twofold problem in which the correction is made for the plan. Then we used actually the corrected area or the true area, whatever it may be, in order to calculate the true area of the field that is being surveyed. Okay. This is one of the UPSC problem, my dear students. Okay. This is for, I think, 2 marks. I taken long back. This was there in my kitty, long back in my notes. So I taken actually UPSC problem also. So that if you can able to solve this kind of problem, then the problems that will appear in the KPSC will be very, very simple for you. Okay. This, I would like to give actually 2 minutes time for you to solve this problem. This is a brain teaser problem. This is a brain teaser problem. Don't think otherwise that sir has to solve all the problems. This is not a classroom. He is asking us to solve the problem. It's not the case. See, I need to understand how far you are following my classes, because I need to evaluate myself. How far you can able to understand the problem statement. Because whatever the problem that I am going to solve actually here, I cannot say so. A similar kind of problem will appear in the examination. We need to understand actually the basic concept of the problem before taking up the problem for the solution. Okay. This is a one-line answer. This is also UPSC the problem for 2 marks. Okay. Let me read the problem first. The field was surveyed by a chain and the area was found to be 127.34 hectares. No problem. Acres or hectares or meter square, no problem for me. Okay, don't worry too much about actually the units here. Let it be the same unit. Okay, 127.34 hectares. If the chain used in the measurement 0.8% too long, a new dimension for the error statement. All this while, they used to say 0.1 meter too long, 0.15 meter too long, 0.05 meter too long. Okay, here they are giving us actually in terms of percentage. What is the correct area of the field? What is the correct area of the field? So how to create decimal system for percentage? How to express 0.8% in decimal system? If you can able to do it, 90% of the problem is solved. That's all. Okay. So as I said earlier, I will give 2 minutes time for you to solve this problem. 2 minutes time. Meanwhile, let me explain actually how to go by. I will give some input also. So here, you know, actually for the area, what is the formula? L by L whole square multiplied by measured area. Okay, I will write MA, measured area. So I need to create this L by L. Okay, and don't tell me actually the information is incomplete. They are not given us actually the length of the chain. We don't know it is 20-meter chain or 30-meter chain and so on and so forth. Okay, nobody will like listen to your questions. because it clearly gives me the percentage. So what is that percentage? 0.8% too long. So I need to use that 0.8% in this bracket L by L. Okay, I am looking at actually the meeting chat. Okay, anybody is trying? Please let me know. If not, I will take up the solution. That's okay. So let me go to the solution. See, true or incorrect area of the field, L by L whole square multiplied by measured area. So in the place of L by L, I am going to substitute 1.008. What is that 1.008? See here, I will write here. 0.8%. Okay. How to express in decimal system? 0.8%. 0.8 divided by 100. So 0.8 by 100 is nothing but 0.008. So 0.008. So irrespective of the length of the chain, I'm going to make use of this. Okay. For example, in the decimal system, it says 0.008. So I can make use of 1.008. 1.008. I am converting percentage into decimal system. Okay, my dear students. So 1.008 whole square, that is L by L ratio is 1.008 irrespective of the length of the chain. If you are making use of 20-meter chain or 30-meter chain or whatever it may be, the percentage of error is 0.8%. So if I consider that 0.8% into decimal system, then it becomes 1.008. So since actually I am calculating the true area of the field, 1.008 whole square multiplied by 127.34, then you will get the true area 129.386 hectares. Okay, just one line answer, 2 marks. This is a problem taken from UPSC. Okay, please do remember. Once again, let me repeat, 0.8% means it is 0.008 in the decimal system. Okay, for example, if it is 1%, 0.01. Okay, 0.8% is 0.008. So how to make use of this 0.008? So it in the decimal system, it is 1.008. L by L ratio becomes 1.008. So instead of 0.8%, if it is 1%, then it becomes 1.01. You got it? How to make use of this? Then I'm going to use actually this value here. Okay. 1.008 whole square multiplied by measured area. It's given in the problem. So it becomes 129.386 hectares. Okay, my dear students. So this is also one of the beautiful problem that will come across in UPSC and as well as KPSC. Okay, this is the homework problem. In the next class, because see, the learning outcome will be evaluated. Okay, learning outcome. What do you mean by learning outcome? Whatever that is being discussed in the regular class, is it being actually followed by the students or not? That is nothing but the learning outcome. So I am giving you two simple problems. Okay, it's very much similar to the problem that I already solved in the class, right? So a 30-meter chain was tested before measurement of the day's work found to be correct. So it was correct actually at the beginning. After measuring 3000 meters, it was found to be 5 centimeter too long. At the end of day's work, after measuring 5400, the chain was found to be 10 centimeter too long. What was the true distance? So First, basically what we need to do, we need to draw a line. Okay, this is 0 meter. This is 3000 meters. This is 5400. 0, 3000, 5400, right? Okay, 5 centimeter too long. It was correct. 0 at the beginning, 5 centimeter. This, make sure it is in centimeter. 5 centimeter too long, 10 centimeter too long. So this is the problem. So here the first distance is 3000 meters. Second distance is 2400 meters. Then you need to apply mean elongation for the first phase of the measurement, mean elongation for the second phase of the measurement. And apply the correction for 3000 meter and apply the correction for 2400 meters and add those two distances, then you will get the true distance. Okay, I am giving you input also. Then there is another problem on the area. Rectangular plot was measured with a 20-meter chain, which was 12 centimeter too long. Okay, the area obtained was 1,17,600 meters square. Find the true area of the plot. This is the direct question. L by L whole square multiplied by the true area. Okay, multiplied by the measured area. So you know the formula. Let me write the formula also. L by L whole square multiplied by measured area, MA. So here, which was 20 centimeter too long. So directly you can use that 20.12 because there is no mention of beginning of the survey, the chain was correct. At the end of the survey, the chain was 12 centimeter. No, it simply says the chain was 12 centimeter too long. So you need to make use of 20.12 divided by 20 whole square multiplied by 1,70,600. So you'll get the answer. See, this is the type of problem that will appear actually in the examination because for usually basically MCQs are for 2 marks. I checked actually all the previous question papers. It is for 2 marks. So when it is for 2 marks, then they cannot ask actually a complex problem. What they are going to do, even the complex problem will be split into simple problems. I will show you actually in the error calculation, tape correction calculations. Okay, there are different types of tape corrections, right? They are not going to ask all the 5 types of tape corrections. You need to pick actually whatever that is required for you. That selection is important. Here also, see, just the formula, substitution, you will get the answer. Even actually for 2 marks, this problem is lengthy. But I saw this type of problem in one of the question paper. That is why I am not leaving any of these problems. Okay. Next, the obstacles. Okay. As I said earlier, during the selection of the stations, okay, you need to avoid the obstacles. Okay, here you will get the answer why we need to avoid the obstacles. Because if there is any obstacles, you need to do lot of construction in the field in order to overcome the obstacle. So we can able to classify the obstacles or different types of obstacles or classes of obstacles, like obstacles to ranging but not chaining. Obstacle ranging is not possible, chaining is possible. Ranging, okay, it's not possible. I think you got to know, you need to understand the concept. Ranging obstacle is nothing but you cannot actually go for any intermediate points. You cannot fix any intermediate points. Ranging is not possible, but chaining is possible. So there are certain classes. Obstacles to chaining, but not ranging. Obstacles to chaining, but not ranging. Chaining is not possible, but ranging is possible. I will give you some examples. Obstacles to both ranging and chaining. Ranging is also not possible. Chaining is also not possible because obstacles are there. Okay, once again I repeat. First one is obstacles to ranging, but not for chaining. Next one, obstacles to chaining, but not for ranging. Obstacles to both ranging and chaining. Right. Now we'll take up in detail. So obstacles in chain and tape surveying. Okay, sometimes we say chain surveying or as well as tape surveying. So obstacles to ranging but not chaining. This type of obstacle in which the ends are not intervisible. See here, A station, B station. Ends are not visible. There is a small mound. B is at a somewhere at the depression. So if I stand at A, B is not visible. So there may be two cases of this obstacle. Both ends of the line may be visible from intermediate points. Please do remember. Both ends of the line may be visible from intermediate points. Both ends of the line may not be visible from intermediate points. So in the first case, we know how to solve it. We'll go for what is called as reciprocal ranging, right? Both ends of the line may be visible from intermediate points. If I select actually intermediate points M and N, A and B are intervisible, okay, from M and N. But A and B are not intervisible, but from intermediate points, they are visible. Then I can easily go for what is called as reciprocal ranging or indirect ranging. If the points are not visible from intermediate points, then I need to go for what is called as random line method. Okay, random line method. When you are going to employ a random line method, my dear students, when both ends of the line may not be visible from intermediate points, because there is a large mound, they are not intervisible. Okay, then I need to go for random line method. What I'm going to do is, okay, here there is a large mound. I will take a random line away from the chain line. Okay, from A to B1. Okay, from B1, B is visible. So I'm going to erect a perpendicular here. You can see the perpendicular. Okay, similarly at D1, I will erect a perpendicular, and C1, I will erect a perpendicular. A simple way of erecting the perpendicular. Now I need to calculate actually the distances. Okay, CC1 distance, DD1 distance. You can see here CC1 distance, DD1 distance using similar triangles. Very simple. Okay, let me take up this here. So CC1 is equal to AC1 divided by AB1 multiplied by BB1. This is similar triangle, right? Because BB1 is possible to measure. I can measure BB1. Similarly, DD1 can be calculated using AD1 divided by AB1 multiplied by BB1. So here AD1 can be easily measured, AB1 can be easily measured. So I can calculate DD1. So like that, I can erect perpendiculars any number from the random line, any number. So CC1, DD1, EE1, FF1, like that I can go for any number of calculation. Then I can mark C, D, E, F, like that actually on the chain line. This is called as a random line method. Okay, nothing to do with reciprocal ranging. Once again, let me tell you, reciprocal ranging is used when intermediate points, the stations are visible, whereas random line method is used when stations are not visible from intermediate points. Okay. Right. Next one is obstacles to chaining, but not ranging. Okay. obstacles to chaining, but not ranging. So there are two classes here. Under this, there are two cases. One is nothing but a simple pond. The second one is a river. So how actually a surveyor will look at actually these obstacles? The first obstacle, pond. So if it is a pond, it is possible to chain around the obstacle. You can go around the obstacle, right? Simple. You can go around. See, this is the pond. It has got a finite distances, a finite area. I can go around the obstacle. This is one type of the case. The second one is, it is not possible to chain around the obstacle. If it is a river, if it is a Kaveri river, it starts actually in Coorg and ends up actually in Bay of Bengal. It is infinite almost in our basic survey. So how to overcome actually those obstacles? It is a different methodology altogether. So one by one I will take up. Okay, let me explain one or two methods here. So the first one is, a pond is an obstacle. Once again, please do remember, both the cases falls under obstacles to chaining but not ranging. Okay, chaining is problem, but ranging is not at all a problem. So in the first case, okay, I am not going to read this sentence. It's a very simple one. A pond is there. So you can actually consider two stations, A as well as B on either side of the pond. What you need to do, erect perpendiculars, okay, at A and B, such that AC is equal to BD. So when you make AC is equal to BD, then CD is equal to AB. Simple, because it becomes a rectangle. A simple way of overcoming the obstacle using our simple geometry. Always make sure that use a simple methodology in the field. So next is, once again, the same point. Here, what I'm going to do is, at the near station, okay, at the near station, erect a perpendicular. Okay, join BC. But this BC line should not actually fall on the pond. It should be away from the pond. Then you can easily calculate AB using your Pythagoras theorem. AB equals BC square minus AC square, because BC is the hypotenuse, AC is the opposite side. So you can easily calculate AB by using root of BC square minus AC square. Simple mathematical equation. Next one. Here, you actually draw a line, set a line AC, and fix a line C away from the pond. At C point, you can take a perpendicular. Okay. First, you take some known measurement and mark C station away from the point. At C, erect a perpendicular such that it meets actually the chain line at B. So this is one of the construction. So here the advantage, you can select actually the C station randomly. So less number of people required here. So you need to have some basic mathematical ability while conducting surveying. Okay, depending on the people availability, choose a relevant methodology in order to overcome the obstacle, right? So this is a simple obstacle. So you can make use of an optical square, stand at C point, okay, a random point, and erect perpendicular so that those perpendiculars meet at A station and B station on the chain line. Then calculation is not at all a big problem. Use once again the Pythagoras theorem. AB becomes the hypotenuse, root of AC square plus BC square. Simple. So when you are going to employ this, and the number of people available is very less. Okay, so that only 2 are there people. Then what are you going to do? You are going to erect a ranging rod here and ranging rod there, and using a cross staff, an optical square, you can erect a perpendicular, measure AC distance, measure BC distance, and calculate AB distance. Next is a complex way of solving the problem. A complex way of solving the problem. This is a regular problem that will appear here and there. So that is why I've taken this. This uses actually the cosine rule. Okay. So I think you're all familiar with the cosine rule. So I will take up this methodology after a break. Okay. So I will give a break now, half an hour. Thank you very much. Please rejoin once again for the class at 11 a.m. Thank you very much, my dear students.